My name is Faraz. I am the co-organizer at TMLS. Thank you for joining this workshop. Just a quick announcement that the actual summit tomorrow and day after is going to be hosted on Hopin. You all would have received an email yesterday or earlier today for access to the platform. All of the workshops videos are being recorded. They will be shared by the middle of December. We will also be sharing all of the resources and slide as well. I'm happy to welcome Elle. Elle has been quite a bit champion for our community. We also had her on last during the ML Ops session as well. So and over to you, Elle.
Hi. All right. Thanks very much. Thanks for having me. I'm really excited to be here. Like Faraz had said, I did a meeting back in June, and I had a really great time. So I think TMLS is doing some really great stuff. It's a nice blend of, like engineering and data science and machine learning. So I'm really happy to be here. And so if you're here at this workshop, I'm assuming that you are looking to learn a bit about what GitHub Actions, can do in, maybe your machine learning or data science projects. How I'm going to structure this is I'm going to do a bit of talking with some slides in the beginning, kind of to introduce like where we are, what the problem is, and then I'm going to switch to some live coding. And when I get to the live coding part, I will do my best to keep my eye on chat. So you should put any questions that you have in, and I'll try to answer them in real time to the extent that I can, because I feel like that's one of the best parts of live coding. So let me just jump in with some slides. So here we go. I'm going to do a share screen. All right. Okay. So I'm guessing you can all see my screen. If you're having any problems, let me know. So a little bit about me first. So my background is as an academic researcher. I worked in a lot of neuroscience and computational biology labs. And when I was finished up with my PhD, I felt like I was much more interested in how we use computational tools to do science than I was in researching the brain in particular. So I wanted to work on methods for doing rigorous science. And so I joined a startup called Iterative, and we make DVC, data version control. That's kind of our flagship project. You might know DVC. We call it like Git for data science and machine learning, but to be completely technically transparent, DVC is not a replacement for Git. It's something that extends Git version control. So you use Git and DVC together, and it helps you add, remote storage for big files like data sets and models to your Git repository. And so this is kind of, where we are as an organization, and that we look at kind of, both engineering and machine learning, and putting them together to make rigorous software practices that are going to work, for very complex projects. So I want to start kind of talking about, what is the problem that we're trying to solve here? And how did we get interested in looking at, things like GitHub Actions in the first place? So I want to start with this figure that I love from a case study of teams all across Microsoft. So in this study, the authors reported that teams, whether they were working on speech or search or ads, were all following a pretty similar and stereotyped workflow on any software project that involved a machine learning component. And of course, there's a lot of different folks that are following all these steps. So we have data engineers whose job is to, collect, clean, and label data scientists who engineer features and train and evaluate models, and software engineers who work on deploying and monitoring applications built around those models. And I love this slide because I just wanted to put a bunch of baby animals in a corporate structure, and here they are. Anyway, this all works well in theory, like if everybody is passing things off to one another, like a relay race. And of course, that is almost never what happens. So we know that machine learning models, to work really well in production, there needs to be feedback. So software engineers and data scientists might have to pass several modeling experiments back and forth. And data scientists need to be able to anticipate the system constraints of software engineers who will deploy their models. And we don't have this. We have a lot of, great models that work on our laptops, and then they never get off our laptops. And so it's almost like, what was the point? And finally, everybody needs to know, where does your data come from? Where is this data from? And does it match, what kind of data is coming in now? And so there's really a lot to manage. There's a tremendous amount of complexity, and even though machine learning is a new part of the software engineering workflow, relatively speaking, it hasn't been easy yet to, just slot it into our software stacks and, just keep going. We find that a lot of machine learning projects really get stuck around some of the issues that I've been talking about. So we've kind of drawn some inspiration from the field of DevOps, and DevOps is a portmanteau of development or developers and operations, right? So DevOps, development and operations. And so it's kind of like it's a philosophy, a peace treaty, and also some very practical steps that have been really revolutionary in the way that software engineering is done. And specifically what we mean here is that, there's in traditional software development, there's been conflict between developers who want to build cool new features and they want to explore and test them out and they want to rapidly develop, and operations specialists who are kind of like our engineers here, who are, they want everything to be as stable as possible, and exploring and making new things fast and maintaining stability and availability of your service. They can be at odds. They have competing incentives. And so, DevOps provided a set of practices that most major tech organizations have incorporated now, things like frequently committing, automating a lot of tests, and that it makes it a lot easier to go from exploring a new feature to deploying it without any interruptions in service. And this is opposed to, many years ago, where it might have taken, months and months and months to deploy something. Now, a lot of organizations deploy new code several times a day, even several times an hour sometimes. So this is kind of inspiring to us, to see, well, can we bring some of those practices to machine learning? And data science development. So that's kind of our hope here. We're hoping, can DevOps help? We think so. And so one of the big ideas from DevOps, which has really changed the way that multidisciplinary teams run, is continuous integration and continuous delivery, which we can abbreviate CI/CD. And I'll try to explain this really quickly. So CI/CD is a practice that establishes collaboration rules between developers and operations specialists. So to take a look at what that means, when somebody makes a change in your source code, a build happens automatically, and then some tests get run on that build. And if the build passes the tests, the modified source code becomes a candidate to be merged into the main branch of your project. And if not, you can keep iterating. So you're getting some automation, right? Your tests are run automatically and you get fast feedback. And this really helps speed up development cycles. Now let's take a look at what's different when machine learning is part of the workflow. So first off, it's not enough just to monitor changes in your code. You also have to monitor changes in your data set. If your data set changes, that will completely change the outcome of your model. Next, instead of building software, we're often training models. And training models can sometimes require some very specialized hardware. And finally, instead of doing these pass-fail tests, a lot of times we need to have more information than that. If we're trying to decide, is my latest experiment, my new feature, is this really helping? Is this an improvement over what we had, or does it pass, some benchmarks? We might need to report quite a few numbers. For example, our overall accuracy could go up on a classifier, but if precision goes down, that may or may not be acceptable depending on, what is the context of our project. And so we'll often need a domain expert like a data scientist to come and look. So for all of these reasons, we like CI/CD, but it hasn't been trivial to use it in machine learning. So just to summarize, some reasons why it's not that easy just to add in your machine learning is one, version control can't always track changes in data sets, right? So if we need to version our data set as well as our code, it gets hard sometimes when your data sets are quite large and they don't fit necessarily into, your typical Git version control setup. Training models isn't like building software. We can have some, particular hardware dependencies here. And evaluating models is just more complicated. So what we think is needed are tools that extend CI/CD practices from software engineering to machine learning. And this is what we do. We make tools. So here's kind of a wish list of some of the features that we want for CI/CD to work for ML. We want to be able to version data like code. We want our CI system to be able to allocate whatever hardware is going to be needed to train models. And we want metrics about model performance to be reported in an efficient and human readable format, maybe even with data viz. So I'm going to show you how we've been approaching it. And so this is a collaboration I'm working on with Dmitry Petrov, who's the CEO of Iterative DVC creator, and our developer, David Ortega. And so we're kind of capitalizing here is some really cool developments in the Git ecosystem. So we really like Git tools, right? So DVC is built around Git. And we like Git tools because they're so well established in the software development community. And we think they can be adapted to work better for data science projects. So two services in particular have really caught our attention. There's GitHub Actions and GitLab CI. So these are systems designed for Git-centric continuous integration, and there is tremendous overlap in what you can do with GitLab CI and GitHub Actions. For the purpose of this workshop, I'm just going to focus on GitHub Actions because of its, I think the barrier to entry is a little lower if you're totally new, and they have a lot of like free time on GitHub Actions if you're working on a public repo. But everything I'm going to show you, you can also do in GitLab CI, and we just merged our Bitbucket cloud support too. So just so you know. Okay, so the project, this is our open source project working on making GitHub Actions work for machine learning, and it's called Continuous Machine Learning. This is our super cool logo. Two ways to follow our open source project where we're kind of developing all these resources. We have a website and we have a GitHub repo. And so kind of to go back to this figure to maybe help conceptualize like where do GitHub Actions fit in this, it's this part. So we can use GitHub Actions to provide the compute power to maybe train or evaluate a model and report back some tests, and put those tests into our, right into our pull request. Okay, so you can also, I'm trying to explain this. If you have never seen GitHub Actions before, another way to think of it is that GitHub maintains some computers. They manage them, it's all theirs. And you can, have them run a job for you. You can just specify like a recipe and they will, have their computer run the recipe for you and report back the results. So I'm going to start by showing you how, how this kind of looks, and then we'll go into our live coding example. So if we were to have a project on GitHub and we're using GitHub Actions to automate training and evaluating a model, how it works is that we're going to create a YAML file that's always going to be in a special file path. You're always going to put a file in GitHub/workflows. And as long as it's a YAML file, this kind of tells GitHub, hey, we've got an action. You're going to want to run this workflow. What you do is you'll set a trigger and you'll say, okay, when our repository gets a push, that's when we're going to run the workflow below. And we can set things like what kind of machine do we want to run on? So I'm picking the operating system. I'm also saying a Docker container that I want to pull. And then I can just run some stuff. I can, create a Python job. So here I'm going to install some requirements, run a Python training script. And then finally, the last thing I'll do is just using some bash scripting and some CML helper functions, I'm going to write a markdown report. And then that markdown report is going to get delivered to GitHub as your pull request. So it's going to be like a comment on your PR. And so, the hope of this is that then everybody on your team can take a look at something like this that has maybe some metrics, maybe some data viz, and they can discuss and say, and you can kind of treat this like code review. And then, hopefully you make a more informed decision about, what you're merging. All right, so I'm just going to jump now into some coding. Let's see. All right. And I'm going to try to pull up, if I can, chat. I'm not sure if I can see it while I'm screen sharing. Oh, I don't think I can. Let's see.
Are you looking for the questions, sorry?
Oh, I see the chat. Here we go. I found it. Okay, cool. I just wanted to have it up. All right, so I'm going to start doing some live coding, and I have the chat visible. So if you've got questions about what I'm doing, this is it. And I see a question about data egress. I think I can answer that as I go. So GitHub Actions provides a lot of very free stuff. So when if you want to try this out, you get a certain number of minutes on their runners are what we call the machines that they're using. And so you should be able to have, for most starter projects, it should be just fine. And so you won't typically run into any ceilings on, what I'm going to show you this kind of work. So what I have here is just a pretty plain GitHub repository. And so what we've got is a fairly standard, honestly, oversimplified. I'm sure a lot of you that work on machine learning at work have far more complex setups than this, but for the purpose of emphasizing GitHub Actions, I'm going to use kind of a Kaggle problem, literally a Kaggle problem. I've got this wine quality data set here that has, a bunch of observations for some properties of wine, and then a rating from some wine experts. And I have a Python script that's going to take that data set, split it up, fit a fairly basic random forest regressor on it, and make some plots. I'm going to write a metrics file that just prints out, what's our train score, what's our test score. I'm going to make a plot of feature importance. So a bar graph showing in my random forest classifier the relative importance of the features. And I'm going to make a plot of some residuals. So how far off are my observations from their predicted values? And I've got a requirements file. So this is, these are the libraries that we're going to need. And I can totally copy and paste the GitHub link here. Here we go. Okay, so let's see. So right now, this is an ordinary GitHub action. There is nothing special about it at all. So what we're going to do is open up a new branch, and we're going to add a workflow file. All right, so let's see. I'm going to do add file, create new file. I'm going to call it .github/workflows, and I'm going to call this, let's see, let's give it a name. I'll just call it cml.yaml, just to be a little boring. But now I'm going to go to my CML repo over here to kind of grab a template. This is just something that I kind of recommend doing. We've got a pretty basic template here that you can copy and paste, and this will kind of get you started. Okay, so what we can do is name the workflow, and I can call it wine quality model. I'm going to keep the trigger on push. And I want to say, let's do on Ubuntu, same operating system. I'm going to keep the Docker container that I had. This Docker container contains some CML helper functions. Just note, Docker container is not the only way to get these. So this is, still workable if you have your own Docker container. But I won't go into detail about that here unless people want to. And then we've got this. This is kind of standard GitHub Actions template. So it's totally cool if you don't know what this is, but it's just kind of boilerplate stuff. So you can just copy and paste it. And I'm going to call this train wine model. Actually, this can be in kind of human readable. And again, this is kind of boilerplate, so don't worry about that. And so I've got this pip install that are requirements. And in this script, we've got, it's only train.py. Oh yeah, I can make this a bit bigger. All right, so let's do Python train.py. And the first thing, let me know if you need it even bigger. I can do that. Okay. And now let's just do some bash scripting right here. So it did create a file called metrics.txt. So this script is going to create a file metrics.txt. So I'm just going to do cat metrics.txt and just kind of print out the contents. So let's create a new branch, and I'm going to call this add, let's just do workflow. Okay, so once I open this pull request, okay, and now we can see that something is running, right? So we've got this little, it's lighting up, very cool. So let's take a look at that. If we go to details now, we're taken to this dashboard. And what we're seeing is basically the logs from the runner. So we can see we've got setup job. And so some of these like setup job, initialize containers, these are, kind of defaults for, we have a Docker container, it's always going to run that. And we can see here's our special train model for wine quality step. So this will take a minute. One trade-off about, I think continuous integration or using GitHub Actions is really cool, but it is definitely slower than running things locally. So deciding, where you want to fit this into your workflow is up to you. Like some people will do a lot of development locally and then kind of check in only their favorite local development into GitHub and then only run their job on, maybe that. Because of it's not as fast as like iterating on, it's just not as fast. Let's see. Not sure what it's waiting on. Just slow. Let's see. There we go. Now it's running. We're installing the requirements. So this just looks like pretty typical output of your pip install if you were doing that locally. And there are some tricks you can do if you want to kind of cache your requirements so that they're not installed every time. But it's up to you. There's some trade-offs. I mean, I kind of like having your requirements installed every time because it's like you're really testing, from a completely clean slate. And I think that has some advantages for being really isolated. But it's up to you. And so if we take a look here, we did this, and now right here. So here's what I printed out, right? So we did cat metrics.txt, and that printed out, how well we had done. And that's okay, right? But we kind of would rather have this info not like buried in our logs where somebody has to dig through, but we'd really like it to be visible actually in our pull request. Right, so now I'm going to show you how to do that. Okay, so if we go back to code, and I'm going to go onto this branch, I'm going to go into here. We can do like this, cat metrics into reports.md, and then I'm going to do CML send comment, which is a helper function for reports.md, and I'm going to do start commit. Okay, and now we can kind of wait and watch this. So we'll go back to our pull request. And again, we have this yellow dot. And we'll just wait. Okay, so in the meantime, we've got this question, can trained data be cached? Still scared on data egress. So I'm guessing if you're asking about data egress, that means that you have maybe like your own resources, like you want to connect to an S3 bucket or something. and you're going to transfer your data to the runner. Yes, you can do caching. I think you can also mount your data somehow. But yes, there's somebody had a question about this recently that's in our Discord channel that had worked out a way to cache their training data because it didn't change. So you should be able to do that. I won't say it was super easy to do that, but you definitely can. So yeah, if you have absolutely huge data and you're worried about, the costs of transferring it maybe from your S3 bucket and you don't think it's going to be free to do that, then yes, there are some tricks you can do to make it so that you're not transferring it every time. The only thing you'd want to be careful about is making sure that your data truly doesn't change. Because if your data if it's at risk of changing, then you really do want it to, be transported. So feel free to ping me after this and I can try to connect you with the solution that a user had found for this recently. All right, so we're just waiting. And again, we've kind of got this here. Oh, thank you. This is great. All right, we're just waiting on the run. How could I integrate an HTML page if my report tool generates an HTML file? You can print HTML into your comment. Anything that can go in a markdown file can go in a GitHub comment, right? Because markdown can take HTML. I can show an example of that actually right here. So I've got, now we've got this data is added into our comment. So that's, that's pretty basic. Is there any limit on what kind of jobs we can specify in the YAML? Not really. I mean, it's pretty open-ended and there's lots and lots of GitHub Actions for integrating, with lots of different tools. Resource-wise, no, it would be bounded by, what you have on hand. I will talk a little bit about something called self-hosted runners in a little bit. So I'll get to the end of this example and then I'll talk a bit about self-hosted runners. Okay, so now we've got our text printed, but let's also talk about, adding some pictures to this. So again, we've got some helper functions and let's see if I go to here, my workflow, let's see, going into here. All right, this time I'm gonna add some pictures. Okay, so first I'll do add text. So I'm gonna make like a pretty header. I'm gonna change this to append. And now let's do add pictures. And let's do first feature importance. Okay, so now I've had, and like, I'm just copying this from, my code here, but we had a figure that was created called featureimportance.png. And so I'm going to use this function CML publish featureimportance.png. And then I'm going to just use a flag for this particular function. And so feature importance is going, it's just this bar graph, and I'm saying use this helper function that we've made CML publish to put it into markdown form and put that into your report. And then let's do residuals. And now I'm going to do CML publish residuals.png. All right, and then finally we're going to, I'll just put this here, send the report. Okay, so we're hoping that we're going to add our feature importance graph, then our residuals graph, and send that off. Okay, so we're going to be at our pull request, and it's going to take a minute. And while that's going, I'll just show off. I'm going to show you this action I did recently that includes, it includes some, what's it called? Here we go. So this is actually an HTML table. I was using an R package that prints off, it's called Cable, it's an R, and it prints HTML formatted tables. And so this is an HTML formatted table, and I just dumped the HTML code into my, into the Markdown report, and it prints. You won't get anything interactive. One downside. So basically any kind of code that you can use in a GitHub Markdown file, like on the README or in a comment, you can put here and it should work fine. You can actually embed things like video and audio too, or at the very least, you can embed links to them. So this helper function that we made CML publish, it just kind of uploads whatever your file is to some storage that we have. And then if it can't actually display it in your comment, it will still provide you a link for it. And that means that you can have like an audio file, you could have a PDF, and if it can't actually be embedded in GitHub, if they don't support that in their Markdown, you'll still get a link and that will take you to it. So you can in this way kind of query like, this is an output of my model. And then you can still take a look at it no matter how strange of a format it is. All right, I'm just going over here just to give you another look at like what this is like. Okay. If I go to actions, we can see a bit more of the dashboard here. And so you'll have the dashboard for all of the past, past things that we've run. Good question here. Are there any tools for data versioning or direct? Okay, is there a good succinct cheat sheet type resource for relevant GitHub actions? I haven't really found anything that's like a cheat sheet yet, because GitHub Actions is still relatively new. I think this came out in 2019 or so. So I'm not sure of anything. I feel like I kind of had to learn it all a bit of the hard way. So part of why we're, making some resources now. Actually, the docs are really good. I have found that the GitHub Actions docs are quite good. So reading those, if anybody else has anything that they like, feel free to do it. Another thing that's cool is that there is a GitHub Actions in Marketplace, and this way you can browse a lot of actions that people are making. And I feel like that is pretty informative and interesting and gives you a lot of ideas of what you can do. Are there any tools for data versioning or directives for recreating the same experiment output? Yes, I will show you that. That's DVC. Okay, so now when we go back to this pull request, we're going to have, here we go. We've got not only our metrics, but we're going to have our plots of feature importance and our residuals. And here they are inside our pull request. Okay, and the last thing I'm going to do here is I will do, let's go here. I'm going to now actually change my, change something in my model. So in train, I am going to change, let's see. I fit in my random forest regressor. It was super shallow. It was max depth of 2. So I'm going to make this a bit deeper and see what happens. Making it deeper hopefully means we can learn some more interesting and complex features. So I'll go here and let's see if our results get any better. Let's see, where is the CML publish helper function coming from? So that's actually in our Docker container. That's how we got it. There are other ways, if you don't want to use our Docker container, is that you can install the CML publish function as well as the other helper functions using NPM. So you can either NPM install them inside your own Docker container, or we are actually releasing in the upcoming weeks a very modular GitHub action so that you can, load them in very easily. So keep an eye out for that. I hope that answered the question. Yeah, this awesome actions repo looks quite, oh yeah, this looks really good. Yeah, this is good. Thank you, that's really helpful. Yeah, that looks like a great library. Let's see. Okay, so while we wait, and we have a lot of docs on our, you know, here on our README for the project. We have a lot of, you know, tips and tricks and kind of uses. We've got some tutorials that I'm not showing you here, but all sorts of things, and how to make like the prettiest pull request you've ever seen. Let's see, are we done yet? This is fine. All right. Any other questions while we wait for this to finish running? Bitbucket, yes, thank you. So Bitbucket support, there's Bitbucket Cloud and there's Bitbucket Server, and Bitbucket Cloud is going to be, we merged it last week and it's going to be released with docs, hopefully this week. Bitbucket Server will be coming out a little bit later, but they're almost, you know, they're both very, very close. And we are working on, you know, making this work for most major CI systems. How does it compare to weights and biases? So it's actually not really a competitor for weights and biases, because to my understanding, weights and biases is like an experiment tracking system. And continuous integration does something that's a bit different. It's making it so that when you commit things into, you know, your project, that you can automatically test them and report those test results very quickly in your repository. Let's see. So this is kind of a way for automating your tests and your checks, whereas I think of weights and biases as like a way to kind of organize your experiments locally. You might use something like weights and biases locally, and then take like your favorite model that you've developed that day and check it into your continuous integration system. And then you could use that to run tests basically of like, does my model work off of my computer? So, right, so the way that we've got things like our requirements file, we're doing it on a totally new machine. It's kind of a way to like standardize test your model in a new and completely controlled and modular environment, and then make it accessible to all the other people on your team because they all have access to, you know, your GitHub presumably. Yes, what if you want to train the model on a more powerful instance? Yes, I will show you about that next. Okay, so to wrap up here, after we had made this change, we get a new comment on our pull request, and I'll zoom out a little bit just because these figures are so big. So we have the old commit, and it's actually, these are tied to the commit. So you could click on this commit and look at all the code at the stage, you know, when you made this. And now we've got our new metrics, they look even better. We've got our feature importance, and now that we had increased the depth of our forest, we have even more, you know, features being involved. So that's good. And our residuals are looking even better. You could go up and compare. So this is pretty great. And we can merge the pull request. Confirm merge. Yay. Okay, so this is kind of, you know, the most basic example. Now, there's a couple other things you can do, obviously, to go far past this. So let me show you a couple of cases where we did even more. So one of them is, what if you want to kind of use like a more rigorous pipeline type experiment, right? So that you want to control really rigorously, like what are all of the steps that I ran, versioning my data. So if your data is maybe somewhere else, I mean, outside of your GitHub repository. So this is something that you can use DVC for. So the way that this is set up here is that we have some data stored offsite, basically. I think it's in an S3 bucket. And then we're using DVC to version our data set. And we also have a pipeline of some jobs that we're going to run. So we have a workflow. And so what we're doing here, just kind of to walk through, is that all of this looks basically exactly the same, except that we are adding some more secrets. So secrets are kind of a way that you can pass things like credentials or keys to your runner in a hidden way. So we're providing some credentials to access our AWS bucket. And then we're doing DVC pull data. So this is where we're saying DVC pull our data set from our S3 bucket to our runner. And then we're using DVC repro, which is a function that reproduces a pipeline. And then we can do a DVC metrics diff to compare how some metric, looks on the current branch of the project versus what's on the main or master branch of the project. And finally, we're doing a DVC plots diff to compare how a loss function looks on the current branch versus what's on the main branch. And so what this looks like, let's see, when I do this. Let's look at this. So for example, this is one where I was comparing what's on the current branch to what's on master. We get a table, right, comparing some metrics, and then we're getting this function here. So here we're using DVC to help us compare metrics and data viz across branches, and then you would have this available when you're deciding, do I want to merge this branch into my repository, merge this into main. So DVC is not technically, it isn't part of CML. It's optional. So we made CML to be totally modular, and you don't have to use it with DVC. Like, for example, the first example I showed you with wine data doesn't use any DVC. But one of the reasons that, we made CML was also to help a lot of DVC users who wanted to make, put their DVC data sets, make them work with GitHub Actions. And so that was, it's an integration that works, although you do not have to do it. And here's a question about where did you set the S3 bucket in the code example? So that would be something that you configure when you're configuring your project. So you could use a function, you'll do DVC remote add, and then you can point to where your bucket is, but it is actually stored in your .dvc config file, and you'll have a pathway here to your bucket, and that plus things like your secrets, which is where you store your credentials, helps you basically, DVC will put together the address to where your data is in that S3 bucket. All right, now let's talk a little bit about how you can use some extra resources. So you can use a GPU by using something called self-hosted runners. Let's see. I'll show first a really simple, I have a video about this actually, GPU, CML GPU setup. So what you can do in your actions, let's see. So I made an action that will run on a GPU, and it's just going to do my NVIDIA, let's see. Actually, that's not a good place to look. Let's see. Oh, I must have deleted it. Okay, I did delete it there, sorry. Basically, you can do something called create a self-hosted runner, and there are so many docs about this. It's quite straightforward to set up because of its kind of, it's a strong part. It's not particular to CML, it's just all of GitHub Actions lets you do this, as well as GitLab CI, where you can say, I want to use my machine as my runner. So you don't run anymore on GitHub's machines, which are kind of tiny CPU instances. You can run on your on-premise GPU, or you can run it on, something like, I don't know, you can pick an EC2 instance. I'll show my favorite one. I think this is it. Yeah. So this is my very favorite one. I'm not going to go into crazy detail because we're actually completely reworking the way that this works, but we made a cloud case where what it does is it deploys an EC2 instance so that has a GPU. So what I'm doing here is a neural style transfer. and I'm printing out to compare what's on the workspace now. So what's on this branch versus what's on the master or main branch of the project. Printing out some info about the GPU. And the cool thing about this is that it will actually turn on the machine for you, and then it turns off when it's over. So you don't have to like log in to an EC2 instance or turn it on through your dashboard. You can just, basically use GitHub Actions plus some code. It's cannibalized from Docker machine, actually, which is a deprecated project, but it's really cool. And so it will allow you basically to turn on the button, turn on your EC2 instance, and then turn it off when it's done. And yes, it can work with GCP instances. It works with GCP, Azure. Those are the Azure, GCP, and AWS are what we have supported so far. But there's lots of flexibility here. So if you are comfortable, like if you have on-premise resources too, you can go much bigger. Like anything that can be added, supported by GitHub Actions as a self-hosted runner, you can use. So there's actually quite a lot of, flexibility here. It's very fun. It's tremendously cool also to use this to like turn on a computer in Ohio. It's like I am sitting here, I make a commit locally, I push it to GitHub, and then GitHub turns on a machine somewhere in America and then turns it off when it's done and reports back to me the results. It feels very cool. And so I think one last kind of use case I want to show, because I feel like I focused a lot here on using this for training, is kind of using this to report more about model testing. So you don't have to do model training in continuous integration. You can do maybe train locally or train using some resources that you're kind of managing yourself, and then check in your favorite model to do like a suite of automated tests. So I have an example here with an NLP data set. So what I have is a data set that's just like, it's just outtakes from, they're lines from Yelp reviews of used car dealers in Seattle. So I just have sentences from it, and I have a sentiment classifier model. So it decides, is this a positive sentence or a negative sentence? And so we're testing how robust our classifier is to perturbations. So the way this works is that you'll have a real sentence from the data set, like, I just love the new Honda I bought from Crystal. And then you randomly introduce a typo. So here, like, I JPST instead of just, right? So we'll randomly insert it. And then we want to find out if our sentiment classifier gives the same polarity, positive or negative, for both of these inputs, right? So if they're the same, so, if this is a positive sentiment, adding this typo shouldn't affect how the classifier, judges the polarity. So we want to find out basically how robust is our classifier. And so what we did here was we created a perturbation test that loads in a model, and I'm using the Hugging Face model. So it loads in the model of my choice, and then I'm using some libraries to basically do that perturbation. And then when I make a pull request, what happens here is that we find out basically compared to what's the model that's on my main branch, right? So what I did is I made a pull request where I had changed the model from Albert to Distilbert, which are just two different flavors of BERT models in NLP. So I'm comparing like this different flavor, and I look at, how well did we do on the perturbation test? How does it compare to what's on the main branch? And then I printed out some failure modes. So these are cases where, we introduced some random perturbations and the model got it wrong, and it was really, really confident, in its, in being wrong. So here was like such an inspiring car, and this is maybe reasonable that if I don't know what this word is, if it's perturbed beyond belief, and this was the key word, okay, I guess I'm all right with that. And so you can kind of get, a bit of an insight into behavioral tests about your model, and they'll be reported here. So I like this as a way to get more granular reporting, and automated, right? So you will not lose track of, you won't forget to run it, or you won't record, your performance by hand somewhere, and then your model changes somehow and you really lose track of it. You're really tightly connecting, you know, in a really permanent way, the current version of your model to these scores, to a comparison to what was on main at that moment in time. So this is kind of another way, right? So you can use this for training, but you can also use this for testing. All right, question. Is there a chance to somehow set up retraining pipelines using GitHub Actions? Yeah, definitely. So the way that I might think about that is, you know, maybe you would set up your GitHub Actions workflow to train your model. You know, take it from like the last checkpoint and then run the training script. And then you could have this be triggered by, you know, a new pull request. And maybe when you get new data, you make a pull request for that. And then that will initiate training. And then you can decide if you want to merge that into the main branch or not. How would you go about using DVC when data must stay on-prem? So the data, I mean, I'm trying to think this through to make sure I don't advise you wrong in any way. But data that is brought to the runner is not visible to anyone else. Like, it doesn't exist off that runner. So it's pretty secure from users. I mean, you'd have to audit it for your own, you know, for your own organization's rules, but assuming you have private data, if you have it on a private, like S3 bucket, right? When it's used by GitHub Actions, it's not in your logs. Unless you were to print out your data, it's not in your logs, and nobody can interactively work with your, you know, GitHub Actions runners, right? They're not interactive. So in effect, really nobody has access to your raw data when you're using GitHub Actions to run a job on them, unless you were to like print it somewhere in the logs, which you don't have to do. You certainly can use on-premise GitHub or on-premise GitLab, but in terms of making sure that nobody has access to your data, I do feel that this is reasonably secure, even using public, you know, GitHub or GitLab. But you certainly can make private repos too. You know, if you have concerns, this will all still work there. And DVC, even if you provide like the credentials here, like, you know, people who cloned your repo, they won't get access to the secrets. And so even if you have like the address to your S3 bucket, people simply can't pull from it if they don't have their own credentials to access it. So it's, you know, I think in that way it is safe. We do have people that use this for health data because it provides some ways to, you know, obscure that data. I think we're running out of time. I think we have only about 5 minutes left. So I'm just gonna open up for any more questions about this. And one note, while anybody thinks of questions, is that you can always leave issues in our project repository, and issues can be things like, this didn't work for me, but they can also be things like, I have this kind of use case. This is the kind of data I have. This is what I need. Can you help me set this up? Or, you know, I use this continuous integration system. Would you be willing to support that? Like, you can also just ask for features or ask for use cases. And that's a really good way to kind of vote for what sort of features you want us to prioritize developing. What is the difference between DVC and CML? Yeah, so DVC is data version control, and it's a command line interface for adding things like S3 storage to your Git project. So it gives you a way to formally link things, big files that might be in external storage, to your Git project. So you can think of DVC as something that extends Git version control. CML, continuous machine learning, is basically a set, like some helper tools to help adapt continuous integration systems like GitHub Actions and GitLab CI to work better with machine learning. So the kind of things that we built in was like, you know, we want to have these really detailed, you know, reports. So be able to report more than pass fail. We built in integrations with DVC, and we've got some tools for using, you know, cloud compute. So that's kind of, CML is a set of helper tools for using GitHub Actions. Any issue integrating CML with on-prem GitHub hosted in private GCP? Ooh, that is interesting. If you don't have internet connection from GCP, I think that could be hard because you do need, I mean, basically GitHub has to be able to communicate with whatever your runner is. I'm not sure. That would be an interesting use case to bring to our support channel, which is here. We have a Discord channel and you can go here and post. So I am not 100% positive about that, so I won't make something up. But I think that our dev team can probably come up with a good answer for that. Yeah, cool. It's a good question. And one more plug is that we have a YouTube channel where we are developing all of these. So if you like listening to me talk about, just like going through different CML use cases, we've got that. We have videos about like getting started. That's like a complete tutorial about how to do this from like 0 to 60, how to set up your own GPU, right here. How to set up your own self-hosted runners, specifically a GPU, how to use this to check your models, behavioral tests. So basically I've got a video about like the typo perturbation test. We've got a video about setting up DVC to work with CML. We've got a video about how to do like a report that compares branches. So comparing your current workspace to what's on the main branch. So all of that is here. And we're continually making more videos. So if you have a use case or something you'd like a tutorial about, just request one. What is the name of the mascot? Our mascot is DV. Wait, I have a DV right here. Hang on. This is DV for DVC. It's extremely important. Right? It's so cute. She's adorable. I love DV. I think I joined DVC about 10% so I could have one.
That is a very cool mascot. Very cool workshop. Thank you so much. This is amazing.
Yeah. Thanks, everybody. Great questions. If you think of anything else, please contact me after on Twitter. I'm just writing it here. You can find me this way. We're always here to help. We're open source. We love your ideas, your helps, your pull requests. So, just let us know what we can do.
Awesome. Thank you so much, Elle. I'll connect with you right after so that we can send out all of the resources and the slides. So thank you so much for your time. This is amazing.
Yeah, thanks.
Okay. Thank you, everyone. Once again, so the video will be shared mid-December, but I'll send everybody all the resources as well. Thank you. Bye.
Bye, everyone.